Ladies and gentlemen, boys and girls, children of all ages, welcome back to geometry. Hopefully you haven't fallen asleep yet. Hopefully you changed channels here, went to part 3 here. You'll see on this one, I don't like the way my drawing looks here too much. I've got the drawing labeled angles 1 and 2 over here. Hopefully it's visible for you guys. Sorry about that if it didn't show up very well. And then the original angle, the bigger angle, is angle ABC. The only reason I threw angle 1 and 2 here is to save you some writing later on, so you don't have to name this angle with 3 letters or the bottom angle with 3 letters. Hopefully you guys can see that. It's not very bold on there, very thick lines on there. We're trying to prove that x is really equal to 10. So I'm giving you the answer to the problem. Whereas on the quiz last week, you had to find the answer to the problem. Now I'm giving you the answer. Show me why that answer is true. And then I gave you these 1, 2, 3, 4 little expressions for the different angles that are on there. So you would definitely start with, and I'm not going to recopy them here on the screen just to save some room. I would recopy these 3 givens here, here, and here. The first step of every problem, just about every problem, every proof, is just stating the given information. So that's step 1. I'm leaving them as blanks on here because I've already got them up here. I don't need to recopy them and have them, be this big on the screen. The second step, this is step 2, not step 1. I've got this equation, and again, you can leave the little m's out of here. I don't care if the little measurement of the angle there is included. You'll see angle 1 plus angle 2 is equal to ABC. All of you know that. If you look at the drawing, it makes sense. The 2 small angles add up to the big angle. The question is, do you remember what it was called when you add 2 angles that are adjacent to each other? What is that postulate called when you add angles that are adjacent to each other? Oh, duh. It's called the angle addition postulate. All of you, of course, know what that's called, but you might not be able to get your words out. That's what we're trying to get you to the point where you can name these theorems and postulates. And a month from now, we'll have 10 different theorems and postulates that you'll draw from and you'll pull from to explain how to do a problem. Today, we've only got a couple simple ones we're going to draw from. So from the last, early in the chapter, section 1.3, we talked about angle addition. There's your reasoning for that second equation. And we kind of skipped this step on the quiz. We went straight to this algebra step where I've got 3x plus 2 plus 18 equals 5x. So we're just sort of reinforcing what we did. But I'm starting with this equation, and I'm replacing angle 1 with 3x plus 2, because up here, angle 1 is equal to 3x plus 2. And again, 2 is replaced with 18. ABC is replaced with 5x, because angle ABC was equal to 5x. Again, you guys know that replacement is called substitution. You should be able to blast through the rest of this proof pretty easily. Try to make sure you can use verbal explanations for each one of these. For example, the next step, there's different things you could do algebraically. I'm going to take the 2 and the 18 and put them together. That is not called addition. So if you write addition here, that is 100% wrong. Addition is when you add the same thing to both sides of an equation. This is called combining like terms. So don't write addition for that step. Be careful. And then, of course, I know all of you would move the 3x to the side. How do you move the 3x over there? Well, you subtract it. There's a subtraction step. And the last thing I want to do, I want to be able to divide both sides by 2. Oops, I went backwards there, and get that equation. Now, I have intentionally set up my x on the right-hand side here. And then look what I did in the last step. Primarily to review a property that you have on your paper today, a new property. The equation got flipped. So there's a new property that we're going to write for that last step on there. So like I said, the explanations are the new thing we're talking about here. What was this called? Oh, it's called combining like terms. What was this next step called? Oh yeah, it's subtraction. Subtracting the 3x from both sides. Then I did division. And then here's the new one. What is it called when you take an equation that's backwards and flip it around? It's one of those RST ones. Reflexive, symmetric, transitive. It's one of those 3 if you want to go back and look at it. And hopefully you realize it's a symmetric property. So I intentionally did this problem with the x on the right side so I could show you an application of where that property is used sort of quickly. You do it all the time without even thinking about it. All right. Last little thing on your paper is a bunch of 7 little one-liners, so to speak. They are not sequential. These have nothing to do with each other. Like 1 doesn't have to do with 2. It's not like the previous problem where step 1 and step 2 are related. Step 2 and step 3 were related. There's no correlation on this last set of problems here. You might need to add some symbols on here. I don't think you have the segment symbols on your paper. So you may need to add those on there for that first one. This is completely on your own. If you're smart, you hit pause and you shut me up for a second. You try all 7 problems and you check your answers. And maybe work with a partner as well and compare with them, just like I'd have you do in class. This is like a 4-minute activity in class, usually maybe 5-minute activity in class, where I give people time to think. Like I said, the worst thing you can do is just copy down what I write down here without actually thinking on your own. So, try to have the discipline to go, hey, I'm going to try these real quick. Okay, here I go. First one, AB is congruent to AB. A segment is congruent to itself. Hopefully you remember, that's a reflexive property. The second one, angle C is congruent to or equal to angle D, and then I've taken that equation and I've flipped it around. Well, the butterfly property is called symmetric. So I make sure I re-emphasize those. The order of the logic matters on this one. Q is equal to 10 degrees. Q plus 5 is equal to 15. Hopefully you realize that I've just done something to both sides of this equation. I've added 5 and I've added 5. That's the addition property. If I were to do that problem backwards, it would be subtraction. I'd be simplifying this. It would be subtraction. The fourth one, get AB equal to CD, and now I've flipped it. Another example of symmetry. Symmetric property, an equation can be flipped around if it's a true statement. The fifth one, and you may have to look at this thing, I've got angles on here. Angle A is equal to angle B. B is equal to C. And then it's obvious if these are both equal to B, then they're equal to each other. It's called the transitive property when you're comparing usually 3 or more things. And you're kind of jumping across to the last equation. And the last one, second to last one. 2 times the measure of angle R is equal to 20. Then the measure of angle R is equal to 10. Well, how did I get rid of that 2? Oh yeah, I divided. And the last statement is the one where you have to complete it, as well as give a reason on here. So it's sort of a double deal here. X is equal to Y. W is equal to X. Let's see, that means that Y and W are both equal to X, which means that Y and W are equal to each other. Hopefully you kind of make that relationship going across those 2 equations, and you set that up as the transitive property. So the completion of this would just be saying that W and Y are both equal to each other. W equals Y, set up by the transitive property. So hopefully this is this is a pretty easy, smooth day for you on your own. I'm hoping you have time in class to attempt the homework assignment. I've shown, the notes show you exactly what a problem should look like, an answer should look like. Should be a pretty easy day. This is due on Monday. Hopefully you're smart enough to avoid some homework and maybe get it done in class, get part of it done in class, and do the rest in study hall. Have a wonderful weekend. Boy, sorry about being absent on Friday. It's my favorite day of the week. Have a good one, guys.